All right, sorry for starting a little bit late. Don't worry, this is a 5-minute talk, so we'll be done well before lunch. No. My name is Dave Boucha. I am a senior engineer at SaltStack, and today we're going to talk about using SaltStack with OpenStack. And as many of you know, SaltStack is used in many OpenStack infrastructures to handle different parts of the many pieces of OpenStack that are out there. And so today I'm going to go through some salt states and describe how you can build out some parts of OpenStack. And then as part of the demo, we're going to run these states and build out just a real simple demo version or demo setup of OpenStack. I actually have a plan. I really would like to, at some point, well, I've already started, but my plan is to have kind of like a reference SaltStack implementation where you have 4 or 5 bare metal servers, run these salt states on them, and you'll have a working, small office type environment to use for OpenStack. So I've just begun that. I'm actually somewhat new to OpenStack myself, and actually running an OpenStack infrastructure, and so that's going to be a really good project. And there's also a lot of pieces that are already built out, so it's going to be pretty good. I'm actually not going to do a whole lot of slides today. The slides were built by somebody else, assuming another environment, so I'll probably skip through a few of them, but we're going to do a lot of hands-on demonstration and stuff. So one moment here. Already using Salt in any capacity at all. All right, great, so a pretty good amount, maybe 2/3. And who's here using Salt already on your OpenStack infrastructures? So we've got a couple. Sorry? Oh, okay, great, good to hear. So when I'm giving talks, I really like to have a lot of interaction. So at any time, if you have any questions or you'd like to make a comment or anything, please feel free to raise your hand, interrupt me at any moment. I really like to have a lot of back and forth and that type of thing. So I won't be offended at all if you interrupt me mid-sentence. So normally when I give this talk, I gave it last week in an OpenStack meetup here in south of Salt Lake. I kind of give a little bit of an overview of what Salt can do. So I'm going to assume that you've already are familiar with Salt, and you're here because you like it, and we're going to talk about some advanced things here. But some of the things that I feel make Salt a really good fit for working with OpenStack are the really fast remote execution, the open event bus that allows you to have data flow back and forth between your minions and your masters. And then also our declarative salt states that allow you to define in a very clean way what those states should be. I've looked at some of the other tools that people use to manage their OpenStack infrastructures and help people convert them to salt states. And I often find them very dense, very unclear. You have to you're programming your infrastructure, so you have to follow through. And what's the logic here? What's going on? And salt states, if you've done right, can be very clear and obvious what they're doing. So that lowers your maintenance costs. It improves your ability to add new features and improve things as you go along. So it makes it easier for your team to be involved when using salt states. Also, another thing, Brian Lane is speaking today from Lyft.com, and he did a study with this company fairly recently where they converted from another configuration management tool, and they went from about 10,000 lines of configuration code to about 1,000 lines of Salt configuration code. So just that management of that data itself is an order of magnitude simpler and easier to manage. So anyway, so let's see what that looks like. So I've set up an environment on the cloud. Actually, my plan for today was to have 4 machines here on my desk and actually bam, have an OpenStack cloud here on our desk. Didn't work out today, so we're doing some of these things on top of Rackspace's cloud, actually. And so it's not going to be a full working environment, but we'll get to see exactly how this works. So let's pull up our environment here. So I have a Salt master. And again, it's a small 512 megabyte RAM instance with some VMs that are pre-built. So see here we have server name Venus, Sun, Pluto, Mars, and then Boucha. Boucha is the minion running on my Salt master. Boucha is my last name, and I named my server after me. These are just running Ubuntu, I'm not sure if it's 14.04 or 12.04, but it's running just Ubuntu server. Nothing's been installed on it yet besides the base install. And can we see the true, okay, the results? Yeah, I think I'll change that color real quick. Oh, it's the, okay. That's going to be harder to change, actually. Okay, so that's the output. Yeah, because Salt is coloring that for us, so I can, if it becomes hard to see, we can do a JSON output, and then it'll just be in black when it comes out. So anyway, so we have the Salt set up, and I'm going off of some Salt states that's CSS Corp built. If you Google CSS Corp OpenStack, you'll find their repo on GitHub. And let's look at what these Salt states look like. Okay, so you can see here, we have Salt states, and these are actually laid out pretty well, that are specific to multiple versions or different pieces of OpenStack. So everything related to Keystone is in the Keystone directory, Horizon, Glance, and so forth. So this is a pretty good example of some best practices. Seth House has a talk he's giving on best practices today, I believe, where he'll go deeper into that. This is a good thing to do. Technically, you could have all these Salt states in one big SLS file, but it's going to that'll make it very much more difficult to debug. And also, this will make it much easier to pick and choose what you're going to use. So today, we're going to use the Horizon states, the Neutron states, and say Keystone, but we're not going to bother with Cinder. Yeah, and the Nova ones. We're not going to do Q today. And that's awesome. It also makes it very easy to split things out on different VMs, or say, like today, I think we're going to run Horizon and Neutron all on one box together. So it makes it very easy to split those out. Let's look at the Verizon states to kind of get an idea. So Horizon. Okay, so here we have, we're making sure Apache is installed. The service is running. This first item on the most left indentation level is the ID declaration, which can be any arbitrary name. So they've named this enable dashboard. Where they're creating a symlink for the Apache to the enabled and the available directories. We're making sure that libapache modwizkey is installed, memcache is installed, that the service is running, and the OpenStack dashboard package is running. That's the entirety for Horizon to set up and define. Yes. I guess if I could zoom the terminal a little bit. How's that? Is that better? Okay. So if you, say a package name changed or something like that, you can see here, it's very easy to come through, find your package name, and modify it to update it. The maintenance of these files is very simple. Obviously, these are very apt to be kept in Git, that type of thing. I have my Vim set up to show white space like that, so I haven't modified all of these, so yeah, that's just a little warning that I got set up, so pardon my Vim clutter. You can blame Seth for that. He hooked me up with that. So.
Just share that.
Yeah. If anyone wants to see that afterwards, I'll put it out, or I can upload it to GitHub or something if you want to download it. And, I like my VimRC. It's simple, but has some nice features for Python development that I like. So let's take a quick look at Keystone as well. So if you're not familiar, if there's an init.sls in that directory, when you apply that state, you can just call it Keystone, and it'll apply the init.sls. These other ones, for example, if I want to apply OpenStack service.sls, it would be keystone.openstack_services. So the init's kind of similar to in Python, where you have the dunder init that does essentially the same thing. So here's the basic installs for Keystone. Again, we're starting with the Keystone package, making services is running. We're watching the Keystone package and this ini file, laying down a Keystone config file. Now, if you notice down here, here we have some Jinja. So this here, in this line, is a very good example of using Jinja. We're pulling this Keystone token out of pillar data and applying it here. This next line down here, not so much. I kind of find that kind of ugly. So it's doing some trying to figure out where to get the right MySQL URL and username and password, that type of thing. So if I had written this specific piece, I would have made that determination in Jinja at the very top, have the logic kind of cleaned up, and then down below, I would use a variable that I'd set up above to get the correct connection information. So you can see here, you start getting too much Jinja all compiled in there. It's just wrong. It's like going back to like old school PHP where you're like, HTML, PHP, back and forth, calling your database. Same principle. You're templating these files, so try to use them in the same manner as you would when you're templating any templating language. But again, here we're getting the connection information. Setting the name of some of the services. I think this is to make it partly cross-platform. This was designed to run on both Ubuntu and CentOS. And they're deleting the SQLite file that I think is the default data store, because we're using MySQL for this. So unless we have any other requests for it, I'm not going to go too much into any of the other states. They're basically the same. Our Keystone configuration here is 38 lines of YAML. I mean, I find it very straightforward. And if you go look at some of the other tools people use, this will be hundreds and hundreds of lines of code that you'd have to piece apart to understand what's going on. Does anybody have any questions? Kind of what we've seen here with the states. They have a couple of custom modules that they've written. So that's how you deploy your custom modules is in the underscore modules directory. Same thing with the renderers. I wasn't aware that they had a custom renderer, but if you wanted to do something else, you would stick that in the underscore renderers, and then those would get deployed to your minions and applied down there. Yeah? I'm sorry, yeah. I know. So the question was, he saw an underscore modules directory and an underscore returners directory in the repo here. And those are used by Salt to deploy custom modules and custom renderers. So they have a module here. I don't remember exactly what it was for. In the newer versions of these states, they've actually, yeah. So cluster ops has some things to do with coordinating the different VMs, and then they have an OpenSwitch module that they've written and added here. So this is a great way to write your own modules. Maybe it's something you want to keep proprietary, or maybe it's something that's not really appropriate to be in Salt proper. We do really appreciate when people submit code and modules back to Salt. So if you have something you think would be very useful in the community and you'd like to be involved, we'd love when people help out with that type of thing. But if it's something that's not appropriate for everybody to use, or it's proprietary, you stick that here in your underscore modules directory. Salt Master will then distribute those out to your minions, and then you have your custom module all ready to go. So that's what that's here for. Same thing with the renderers. So great question. Yeah. Correct. Yes, there are. The question was, thank you for the reminder again. The question was, Keystone is going to require MySQL, and he asked if there is a specific require that will pull that in. I believe, let's look at that Keystone state real quick. So I believe they do that in the top file, and they're kind of depending upon the ordering. So if we go look in the, so this whole set of states is very pillar driven. So they have this whole set of pillar options that you can configure. So the different states, the little split outs, can be seen in the pillar directory. So here we're setting all of these VMs to apply the OpenStack cluster pillar SLS file. And this OpenStack cluster SLS file here has all of our settings. So they have some of the MySQL stuff in order. So I think a more robust option would be to actually do the require, like you mentioned, so that it happens. But here, I think they're just depending upon it being first in the order here that it applies. So, so if MySQL failed to install, then Keystone would attempt to install itself, and it would fail when the configurations didn't work. So that would be an improvement to make on this one here. Yeah, so this pillar allows you to define, so you can see at the top we have cluster entities. So we're specifying the different classes of nodes, so compute node, controller node, network node. You can also add in a Cinder, that type of thing, or queue as well. And then we're specifying right below that which class of node each of our VMs are going to be. So we have servers running, Sun, Venus, Pluto, and Mars. So Sun's going to run both controller and network settings, and then Mars, Pluto, and Venus are going to be compute nodes. So we could actually pull Venus out of compute and make that the network node. So you can see here, this is kind of like a centralized definition of what things should be. Yeah, so then down here we have, lower down they have the list of states that should apply to each type of cluster entity, and that's where they have things in order. So MySQL is before Keystone, so it's kind of depending upon that order, which is fine, but a more robust thing would be to have it require that the MySQL be implemented first. Before we get deeper into the pillar, does anybody have any other questions on the states? Again, if you're familiar with OpenStack, writing these states is going to be very simple for you. It's going to, that's not really the focus of this talk. I kind of want to give you an example of how simple that is to put together. Yeah. So the question is, are they using state.orchestrate or the overstate? They're not in this one. So, and actually that bit me early when I was testing it because the compute nodes were actually up and ready first and Horizon wasn't. So they had to run the highstate again for then the compute nodes to attach in and be visible inside of Horizon. So we'll see if we get lucky on that one today. So a more robust way would be to use state.orchestrate in particular, because then you could say, you can make sure that your Horizon and MySQL and everything is up and running first, and then go ahead and build up your compute nodes and things, build out your dependencies that way. So great question. Thank you. Okay. So we go to 12:30, right? Is that for lunch? Okay. All right, so I won't go too deep into this, but this pillar file is setting up a bunch of bits of information that various things need. We're setting up our MySQL users and passwords for various things here. We're setting up Keystone information that we need, the various services that are going to be running. So this could, possibly, might make sense to split these out potentially. Just how we had the all the states split out and set up, it could make sense to do the same thing here with your pillar data. So as you can see, this is kind of getting long. It might make sense to have, all your Keystone related things in its own file or directory, and that type of thing. So that's probably something else that I would modify here. So anyway, this is like a centralized config for the entire system. There's also the, we looked at the top file already. Okay. So if we've set up all of our pillar data, so I'm going to refresh all the pillar. All the pillar data. Okay, that's all been executed. So now we can use pillar data to execute commands on our VMs. So I is for targeting. So we're doing compound target here. So we're using pillar, the cluster type, OpenStack. Let's do test.ping again. Let's make sure we're matching. All right, so now we're going to time this. So let's actually, all right, so we're going to time this sucker. This earlier today, it took 4 minutes and 7 seconds. So we're going to let that go. And again, I also did have to run the highstate twice because the Horizon started up just a few minutes or a few moments after the compute nodes, that type of thing. So people use SaltStack again to both stand up and control and build out their OpenStack infrastructure. But Salt also works very well and tightly using Salt Cloud against OpenStack's API. So I do this all the time. In fact, we're doing this here. We're using Salt Cloud to connect to Rackspace's OpenStack API. And so you get the best of both worlds, managing your actual cloud infrastructure, and then also managing all the VMs and infrastructure that's running production on top of it. So again, so from bare metal all the way to your VMs, your Docker containers, Salt works really well with your OpenStack infrastructures. What's that? Yeah, I should play some Van Halen or something. Where we're going. Yeah, we'll have a few failures because Neutron's going to have some issues because we're not really controlling the networks and stuff. So we'll see a few things fail in here. So that was one of the which VM was this one? Okay, well, we'll see here in a second. So let me show you a couple URLs while that's going. So like I said, if you Google CSS Corp, OpenStack, GitHub. Okay, we're done. 2 minutes and 29 seconds. So here's this project. Again, they're using this in production, and there's several people that have contributed to it. There's also Cloudbase. Let's see here. Also has one that they're working on. To build out. So these are some great starting points to build out some of these things. So obviously, like a lot of the simpler ones that like Horizon and things like that are working really solid. They're good to go. I'm trying to make these very generic, and so some of the pillar definitions can kind of get complicated because they're trying to make it possible to use different types of networking and all that type of thing. So they're great starting points. So let's go look and see at our Horizon. So let's get the IP address from our Sun server. Okay, so we're in your Horizon. Let's see if the hypervisors. Okay, 2 of the hypervisors showed up. So let's run this highstate again. So the third one will show up here. But anyway, so we have Horizon. We can see our hypervisors have connected in. We don't have any images uploaded. Networking is not going to work in this situation. But you see there. So that took 2 minutes. So I lied. It wasn't in 5 minutes. In 2 minutes and 29 seconds, we had a basic OpenStack setup going. So, so all the things you're learning at SaltConf today and tomorrow apply to the things here using for OpenStack. Again, some of the biggest OpenStack infrastructures use Salt for various parts of it. Rackspace's queuing, storage. Their internal infrastructure, a few other parts are all managed with Salt. Some internal portions of Hewlett-Packard's OpenStack clouds, they use Salt for various things in there. It's just a great tool for managing Salt, especially as you grow from a small environment to a huge environment. Salt will grow out with you. So whether you've got 20 servers in your OpenStack environment or 4,000, Salt handles that like a breeze. So, somebody have any questions? I think we got about 9 more minutes left. There we go. There's a third one there. So like the gentleman said here, if we had done the orchestrate system instead of just a plain high state, then we could have said, make sure that Horizon everything is up first and do the compute nodes last, and then we wouldn't have had that problem there. So when you do a high state, each minion just does its thing regardless of whatever else is out there. So they don't necessarily know if Horizon is ready yet. The orchestrate runner allows you to set those dependencies, make sure certain things are up and running first, and then go on to the other dependencies. So, anyway, that's my talk. If you have any other questions.
So orchestrate, does that serialize the review process essentially? Is there any way to tell it parallelize things? If we use events, tell the master, then trigger essentially orchestration.
Yeah, you can do parallel portions of it. So you could say, like in this example, we could have said, okay, Horizon server, do your thing, get all set up. When that's finished, then just go ahead and do Pluto, Venus, and Mars all at the same time. So you can do portions in parallel as necessary, but you can have dependencies. The other thing you could make happen is if, say, the Horizon server, something fails for some reason, if you make it a dependency, then Pluto, Venus, and Mars won't even attempt to start there. Salt will stop the progression of things. So, there's no sense in building those out if your other dependencies aren't ready. So that's what the orchestrate runner does. So. Okay. Are there any other questions or comments that people like to make? To manage OpenStack? Yeah. So Rackspace uses to manage. So they're a big company. So there's different organizations use different pieces of different software, but their storage is all managed with SaltStack. Their queuing system, Marconi, it's all managed with SaltStack. I believe there's another portion or two. I hesitate to I'm not sure. I don't know. One of the storage guys is here from Rackspace. If you want to come up afterwards, I can put you in contact with him and see what they have, if they have any of that available. So. Oh, it is? Oh, fantastic. Is that the company you work for? Oh, okay. Oh, fantastic. I'll talk to you afterwards about that. That'd be great. So, all right. Well, thanks a lot. And again, I'm Dave Boucha from SaltStack. I'm Dave at SaltStack.com. If you're interested in anything related to Salt and OpenStack, please feel free to get in contact with me on IRC or by email. More than welcome to work with whoever has any questions. So thank you very much.